Thank you for coming. Hopefully we can have a little fun here as we chat and talk about what's going on with OpenStack, particularly as we look forward to 2019. And so if you got questions, let's talk about them, because I could do slides all day, but I'd rather hear what's on your mind. But let's start with a little basic. I guess I should introduce myself. So my name is Alan Clark. I actually work for SUSE, but am heavily involved in open source in general. Been doing open source for long before my hair turned gray. And in the OpenStack community, I'm the chairman of the board. Been doing that for a while too. So heavily involved with OpenStack, love it, have a great time. It's a great community. We'll talk about the community a little bit here as we go along. But I'd like to start by just, so we can level set here, talking about what is OpenStack, right? OpenStack's been going since 2010. We created a nonprofit foundation around 2012. So it's open source software. It's a community gathered around a nonprofit organization. And we're building software for cloud computing, in particular infrastructure as a service, if you go the formal name there. And what it does is it enables virtual machines and containers and supplying your network resources and all the resources you have in your data center, make those available to your customers, right? And so it manages all those compute resources, your storage resources, and your networking resources, and we'll talk about this a little bit. But it makes those available as a data center. So you manage those either through a web interface or through some type of command line clients or through RESTful interfaces, which typically, at least most of the customers I've talked to are doing, because they like to tie it into their business management services. And so really what we're doing is you're promoting IT as a service, right? So when you heard Jim this morning talking about how IT is changing, this is definitely in line with what that's doing. And it promotes things like self-service. It promotes things like, promotes accountability, promotes reuse of your resources, and definitely promotes agility, right? That's the strong points here. Now, as I mentioned, OpenStack's been around for a long time, so the hype, some of the hype has definitely left and moved on to other bright and shiny new things. But it doesn't mean that OpenStack has gone away. I like Fred's quote here. I pulled it out. You know, today OpenStack is the stable system. It's the de facto standard for running private clouds. It really is. If you're doing private clouds, then you're pretty much going to be doing OpenStack. There's very little hype, which is a very true statement, but there's lots of actual usage, right? So we've passed that hype curve and we're on to the real world scenarios, and I'll give some examples here of some of those. So we're well over 10 million cores. I don't know how many months ago. I think this was in Berlin that they gave this, Fred gave this quote, but we're well over 10 million cores. And I know we're well over that because that number came from a user survey. And so you only get the numbers from the people that actually submitted to the survey. And I know there's lots of people using OpenStack that don't participate in surveys. So let's talk a little bit about use cases and some of the successes people have had. And it's quite varied. I just pulled this off the OpenStack website. You know, so people often ask me, well, who's using OpenStack? And it's funny because every time we've had an OpenStack summit, we meet with the press and analysts afterwards. And inevitably, when Jonathan and the team will focus on a particular market segment, the press and analysts will walk away and say, oh, the telcos are all using OpenStack, but nobody else. We're going, well, no, that's not the case. We just happen to focus on that market segment. So it's quite varied, and we've worked with a lot of these folks. So just to give you an example, Adobe. Everybody's familiar with Adobe? You know, even if you don't realize it, you're familiar with Adobe. You know, all those little pop-up ads when you go browsing, and all of a sudden that pop-up ad seems to know what you were browsing for a few minutes ago. You know, that happens to me all the time. I go search for it. Just happened. You know, anyway. You know, all of a sudden those personalized ads are popping up. That's Adobe, right? So they're running OpenStack. They've got over 100,000 cores running their business. They're I apologize, I'm looking at my notes here so I can get the names correctly. Their high volume bidding application is what they call it. So they've got over 100,000 cores. What's very interesting is they're managing that with just 4 engineers. Okay? So very high scale deployment, keeping costs and so forth in place. So there's a retail. Target's got Walmart. Other companies have got OpenStack rolled out. Target's running over 30,000 cores on their system. And one of the big reasons they've pulled it is because they're actively growing and they needed the agility, the scalability, right, to grow with that. So their goal is to containerize everything. And they're using OpenStack as that infrastructure to enable them to do that. Were we in November in Berlin with our last OpenStack summit? Orlikon, anybody go to the Berlin summit? Did you see the keynotes? Yeah, do you remember Orlikon being on stage? There's the guys he put up, called it a bobbin. You know, my wife sews, so when I see her, she shows me bobbins. They're these little tiny things of thread, right? So he holds up this big spool, he calls it a bobbin, of nylon fiber, right? And so they're using OpenStack. But when you think about it, what they're using it for is they're pushing their infrastructure out to the edge because they're trying to monitor the quality of the thread, right? Because the quality of that thread is their business. So as they're running that thread through their machines and putting it onto these bobbins, they have to ensure the quality of the thread so that they can ensure the quality of the material that they're selling to their customers, right? And so they've rolled out OpenStack as their infrastructure, and they've pushed it all the way to the edge so they can do that. Finance, several examples of OpenStack being used in the finance area. Worked with China UnionPay. It was interesting. We actually invited them to start up a special interest group focused on doing cloud, working to get the banking industry to work together. When we first started talking to them, the reaction was, we don't talk to each other, right? And that's not something we do in our industry. So it was kind of an interesting hurdle to get over, but now we've got them talking together and talking about what their specific needs are for using OpenStack in the finance industry. Cathay Pacific, they've been transforming their infrastructure from what I would call legacy to very much a hybrid cloud architecture style. And by doing so, they've using OpenStack as their infrastructure, and they've been able to increase their throughput by tenfold. So quite an interesting story there. Anyway, we could go on and on. There's just hundreds of examples. These are all published. You can go out there and check them out for yourself. So as you can see, there's a lot of different industries. There's a lot of different uses that are happening with OpenStack. It's not just a particular vertical or a particular market that's deploying this, but we're seeing in several different markets across the industry. So it's pretty cool. And I pulled this quote out from Forrester. It says, the numbers speak for themselves. More than 50% of the Fortune 100 are using OpenStack, right? So if you get somebody that says nobody uses OpenStack anymore, they're wrong. And I actually heard this last week. I had a customer, and interestingly enough, they saw some different numbers and saw there was growth in China, and they inferred from that meant the adoption in the U.S. wasn't happening, and that's not the case. So got lots of adoption. lots of real-world adoption, lots of rollout of all scales, right? I picked out some that are very large. We have many clouds in enterprises that are very small. They're just a few nodes, right? So it doesn't mean you have to have 100,000 cores to be able to use OpenStack and see value with it. That's actually not true. It's not really dependent on the size of your infrastructure. It's more the need of wanting that agility and ability to reuse that's driving the use of it. So we have lots of places that are a very small number of nodes. Now, a little bit about the community itself. So we had over 70,000 code changes last year. Okay? So we focus on, the OpenStack project focuses on 2 releases a year, so a release about every 6 months. 70,000 code changes, that's about 180 code changes per day. That's a lot of code. That's a lot of change. Turns out that OpenStack is one of the top 3 open source projects in existence today. So it's a huge, huge project. A lot of people contributing.
Are those changes OpenStack changes?
So they're in all the components within OpenStack. So when I say OpenStack, and I'll show you a diagram here, yes. Yeah, no, they're all in Nova.
It's my understanding too, like with those changes, we're running on the order of 10 to 20,000 CI jobs every day.
Oh, I see.
All on public OpenStack cloud resources.
Yeah,
So, and
it's into the ecosystem.
yeah, so OpenStack is being used to test OpenStack on. We're not OpenStack Foundation. The OpenStack community doesn't run its own infrastructure. It's running on. I mean, it is running. It's running on public OpenStack clouds that are out there too.
Yeah.
So and so not only is it's multi-cloud, like OpenStack is multi-cloud
By design. So yeah, I should, let me introduce Chris. Chris is from the OpenStack Foundation, and he's here. He'll be down in the booth today. So deep technical questions we can send to him. And then, so he'll correct me. But so let me try to repeat what Chris just said since he's not on the mic. He was talking about a little bit about our process and how those changes occur. We basically have a multi-step process. When you go to commit code, I get my patch ready, say I'm ready to check that code in. We actually have a review process that we go through before I'm actually allowed to commit that code. Once I commit that code, it's been reviewed, everybody says good to go, commit that code. We check it into the tree, that kicks off an automatic test cycle, right? And as Chris was describing, we basically have a public cloud instance of OpenStack that's testing OpenStack, right? And it's pretty much a multi-cloud environment. So all of those changes kicked off new instances of OpenStack to be tested for those changes. Pretty impressive, okay? And we'll come back and if you think about that, the infrastructure that we're using to do that, it's called Zool, is actually being spun into its own separate project because other projects are finding that capability very interesting to be able to take advantage of. So it's being used beyond just OpenStack today. All right, so good questions. Love it. A little bit more about the community. So as I mentioned, we have a lot of growth, a lot of code changes that are being checked into the code base. The number of members that are part of the OpenStack community is over 100,000. That's tremendous growth as well. 187 countries. I haven't been to all of them, unfortunately. Have you been to all of them? No. So I've met people from all over the world. That's, to me, when people ask me, what is it you like about your day job? And I say, it's all the people I get to meet from all over the world, right? And get to associate with and learn from them. And it's amazing how talking to people from different cultures, how those different perspectives actually make better software, right? So it's been really exciting. over 600 different organizations that are part of OpenStack. And we say organizations, not just vendors, right? So this includes other nonprofit organizations, research labs, governments, all kinds of entities that are part of this community. And very active, by the way, very, very active. We have a whole user organization that puts together the forum, part of our summits and meetups and all kinds of stuff. So very active. So yeah, as I mentioned here, the number of community members continues to go up. And we actually, what's the right word? We actually check our membership base here, because to change our bylaws, which we had to do last December, requires a 10% of these people to vote. So we actively check our database to make sure people are still around and active members. And so it's a growing base, and it's a very active base. All right, so as I mentioned a second ago, when I say OpenStack, OpenStack consists of many projects, many different components, okay? And so this is a little bit of a architecture diagram of all those different components. You've heard of the core 10 or 11, like Nova, right? Those are the Nova and Neutron and Swift and Cinder and Heat and Horizon are the most famous you've probably all heard of. But there's many other packages or components that make up OpenStack. In fact, we had 3 new ones created last year. If I can find them. There's so many on here now I can't see them with my glasses. But so we've got so we had 3 new projects. Adjutant is the first one. So that one's spun up. It's a very new one. So I can't see it on the picture here, but it has to do with to improve interfacing into customer management or operations management. So what we're seeing here is we've got the core pieces, and what you're seeing happening here is these other components are starting to build out and interface with systems adjacent to or around OpenStack. So Adjutant's one of those. Quinling is another example. That's a second project that spun up last year that's tying into function as a service. That, if you've heard Niels mention that this morning, or serverless, right? Which is not serverless. And then a third project that spun up last year has to do with, it's called the Power VM Stackers team. And they're tying OpenStack onto the Power CPU architecture, the Power VM virtual machine architecture. Okay, so as hardware expands, or virtualization and abstraction underneath us expands, support gets added there. As the new technology grows around us, we add support on those folks as well. So a big one that you're going to be hearing about this year is around Ironic, which is your bare metal as a service, right? And so forth. So any questions on the components? Or? Okay, so there's lots of different pieces. I mainly wanted to point this out because I'm going to talk a little bit about it in general here in just a minute, but this is by design. Having all these components broke out like this, I think is part of our success, because we're able to keep that by design. Now, as I mentioned, we do about 2 releases a year as a community, and the release that's coming out, actually it came out just a couple days ago, was Stein. They've been going down the alphabet all the way from A, now we're down to S. So the previous 2 releases, Queens and Rocky, if you looked at, well, with 70,000 code changes, that means there's a lot of features. So I couldn't really sit here. I thought I could try to figure out and list all the features. That's not going to happen. So you try to look for themes and give kudos to our technical committee that leads the technical side of this effort, they kind of started focusing on themes. And if you remember 2 years or so back, some of the criticisms in the press and so forth was around the stability of OpenStack. I had a lot of users that were on very old releases, right? And there's been a lot of change since those old releases. And so the technical committee, through their leadership, said, let's focus on some themes. And so they've started focusing on themes with each release. So with Queens and Rocky, one of the themes that they were focusing on was stability, performance, and usability, right? So which sound kind of general, and as you break down into the different components, those words have different meaning, or different specific tasks that need to happen, right? But you roll those together, and we've gotten a lot more stable over these last few releases. And I think that's the proof is we're seeing more and more rollouts into real world scenarios. One of the other areas that they worked on is refining the process. We had a lot of backlog with, like I said, when you go to commit code, it's got to be reviewed. So we had a huge backlog with reviews for patches pending, right? Some of those were very difficult because they were very large. And so in some of the components, they focused on breaking those down, teaching people how to break those down. And so there was a lot of discussion and support just as a theme in the process of committing code changes into OpenStack. And then a third one, which some of the stuff that we work on isn't as visible or new and big, innovative functionality, but are very much required, right? And so a good example of that would be the RBAC policies, right? Security is very important. Nobody seems to care until you get hacked or somebody breaks into it, then they care. Otherwise they go, yeah, I need it, but don't talk to me about it. So that kind of stuff. So those were the themes for Queens and Rocky. And then with Train's the next one that's coming out. Anybody, a little bit of trivia. Anybody know why it's called Train? So I should say the community kind of gets together. They create a short list of words that start with T. Typically it's been cities, names of towns or whatever. In this case, anyway, the community then votes on it, and they voted on Train, which is not the name of a city, but anybody, bit of trivia, anybody know why they voted for the word train? Okay, a little bit of background trivia. So 2 years ago? 2 years ago. So we've had two events. This year we're rolling them back together, but last couple of years, when we started, we had the OpenStack Summit. And the summit was both a conference and the developer summit. And the summits are actually very important for us as a community because it's those summits where the engineers are getting together and deciding what the important features are for the next release. And the engineers were complaining because the marketing guys were taking up all their time meeting with customers at the summit. So we decided to try splitting them apart, and we created what we called the PTG, okay? So we had the summit, which is now more of a conference with customers and users and the whole bit. We had the PTG, which was very developer-focused, project-focused, no keynotes, no big things like that. It was just, each one of those little components, the engineers getting together, having the discussions. So the trivia here is we held the PTG in Denver, and the hotel we stayed at for the PTG was right next to the railroad tracks in Denver. So all the engineers got to hear the trains go by all night long. It was very noisy. And true to our wonderful community, instead of complaining about it, everybody laughs about it now. And we idolized it by calling our next release Train because we're going back to Denver for the summit. but we're not staying at that hotel, unfortunately. So that's kind of some background trivia. Anyway, so these are some of the goals that they're talking about right now. And at the Denver Summit, so this year we've pulled the Summit and the PTG back together. So they're being held during the same week. So these are some of the themes that they'll be talking about at the Denver Summit in the developers section, right? So if you go sit in on the Nova PTG sessions, these are some of the topics that they'll be talking about. So they continue on with improving reliability of the cloud. So testing, reporting, right? Think about usage now. You've got big rollouts. How do you know it's reliable, right? A lot of that is through things like reporting. Self-consistency, doing health checks, particularly for clusters that are in your operations, that kind of stuff. API consistency, that one's very important, right? A continued theme, and still a lot of work to there. Some of them, like I said, aren't as exciting, but doesn't mean they're less critical. So how many years have we been trying to move from Python 2 to Python 3? It's kind of like IPv4 to IPv6. We'll be talking about that till we're all dead. But they're putting a big push on finishing up the support for Python 3. As a user, you go, don't care, but as a developer, it's very important. Supporting Golang runtimes, upgradability. This is a very important one. So, as I'm going to mention later, part of the vision here is our recognition that the world is full of there will be more than one cloud, right? There's going to be multiple clouds. And so you need, and not everybody is on the same version of every cloud. So upgradability becomes very important. So you've got to have consistency, you've got to have consistency across the components, and very much so about cleaning up when you upgrade, right? So there'll be a lot of discussion about that, and I'll come back to that and mention that in a minute. Any questions on that? Okay. All right, as I mentioned, the technical committee put together this vision about a year ago. They started on this, and you can go out here. I referenced it. It's a wonderful document to read, but they're trying to lay out the future vision from a technical perspective, right? And they started it by just kind of defining, okay, this is what our vision is, right? That cloud computing promotes efficient utilization of resources by reducing the transaction costs involved in provisioning and deprovisioning the infrastructure to near zero, right? That's the goal. Bring it to near zero to provision something and deprovision it. And it does that because it differs from the way we used to do things. Then they talk about that clouds are all about self-service. Now, that sounds simple. It's definitely a paradigm shift, but it sounds simple. But once I say that, something dramatic has really happened, okay? So two things. One, the whole flavor of IT has changed, right? I'm now a service organization. If I've turned it into self-service, I'm now a service organization, right? I'm servicing you. You're servicing yourself. But it has huge implications in what I need to do with that service, right? So I don't care whether I'm a public cloud or a private cloud. If I'm providing that infrastructure for you to use, and I'm turning the reins over you to enable you to service yourself, I have to have some type of controls on that. Otherwise, you'll just consume everything, right? So how do I do that? Well, in a public cloud environment, what happens is they charge you, okay? It's a simple cost model. They're happy to let you use all you want, but your CFO is going to get a nice bill at the end of the quarter, right? That's how they regulate it. How do you do this in a private cloud? Typically, a business doesn't charge other parts of the business for compute time. Some do, not a lot. But you do have to, but that whole notion of self-service means that I need some mechanisms for control. So when you look back at that architecture diagram, some of those components in there are all about managing self-service, right? So I may not be billing you, but I do want to make you aware of what your usage is, right? So I've got some monitoring and capabilities. Perhaps tie that into an internal billing system, I don't know. But it also means I want to be able to control how much you consume. So I need mechanisms in there for quotas, right? I need mechanisms in there to know who you are and to only allow you to use certain resources, right? So it's not just how much you use, but what resources I allow you to use. Okay, so it's that type of stuff. So as soon as you start talking about self-service, there's a lot of implications into that. So enables people, gives them the freedom, but it pulls in a lot of other paradigms with it. And that's what all those little boxes are in the architecture. The second part of this is one thing that clouds allow the control of an application's infrastructure to be vested in the application itself. Okay? In other words, what I'm allowing the application to do is help control its reliability. So they're vested in each other, right? So it's no longer just some person sitting there in the IT data center watching a monitor to make sure everything's up and running, but it means I can allow the application to vest in making sure that it's up and running and stable. It also implies that I can create automation, and I can create policy, and I can create reactions based on that policy, right? So I can create heat templates and so forth that orchestrate what to do when something occurs. All right, so as I mentioned before, and as the vision sets out, there will be many clouds. There's not going to be just one cloud. There's going to be many clouds. So we have to ensure that all those clouds within OpenStack, whether they be from SUSE or whoever, that they're interoperable, right? You want them to be interoperable. Within an organization, within a business, you will probably have more than one cloud. We can talk about reasons why, but you're probably going to end up with more than one cloud. You want those to be interoperable. If you don't, your costs go up, your agility goes down. So this also means you need bidirectional compatibility. Talked about upgrade before, right? Not all of those clouds are going to be on the same version. You might not have all the nodes in that cloud on the same version, right? You can get all these differences. So you've got to have that bidirectional compatibility between older and newer components and older and newer clouds. And as I mentioned with that architecture diagram, we've broken all those components out, and they're very separate, and that's on purpose. That was an architectural design from the very beginning. What they've written in this vision paper is that we want to encourage the reuse of functionality, right? You, as a software developer, you want to be able to reuse somebody else's work. You don't want to copy paste, right? Because you copy the bugs and then you got to try to maintain it. So reuse is great, right? So, but reuse with hard dependencies is not so great, right? We've all seen this as a user, the old world of DLL hell, right? You pull in a package and you have to pull in 10 other packages because there's all these hard dependencies, right? So what they're saying is, okay, reuse is great, but be very careful on hard links, right? Hard dependencies. And only do those when it benefits the user. So I thought that was a very good design. Then the last one here I wanted to point out, and there's a lot of other details in this paper that I'll let you go and read. Allow operators to create arbitrary and hierarchical resource groupings. Okay? What we tend to do, it's very natural for us to do, is lay out our infrastructure that matches, or lay out our organization that matches our infrastructure, right? We just tend to lay it out that matches the geography and the way the data center has to be laid out, our racks are sitting, or whatever it be. We just kind of tend to do that, and that's not necessarily how our users think, right? And so the point here is, don't force that onto the users. Enable them to organize the resources in the way that makes sense for their business, not the way that it just happened to make sense because your hardware was laid out that way. Does that make sense? Any questions? Yes.
So, do you have any cloud manager already that can do the scale up and scale down?
Yes.
And how do you think we are going to integrate? Let's use example. We have OpenStack as an infrastructure for the cloud, but we hook some CAD solutions, some CAD solutions.
Yep.
And to me, we have some Elasticsearch stuff to do the dashboarding, Grafana, Kibana, whatever.
Yep.
And every solution has its own component, like billing, logging, and whatever. So how do you think we can work together to do, you know what I'm saying?
Yes.
It's more customer-centric, it's more business-centric.
It is, yes. Yeah, so for the mic, because they're recording this, let me try to capture your question in 4 words or less. So basically, we've got all this business infrastructure that's around OpenStack. We've got our own billing system, we've got our own monitoring system, ticket system, and so forth. How do I manage those with OpenStack in this infrastructure? How does that OpenStack tie into those? That kind of a good summary, más o menos, more or less. So the answer is that's what a lot of these components here are about. They're not recreating technology, but they're interfacing with those technologies. Okay, so we do have some, like Horizon is a graphical interface, right? Provides you that graphical view. But some of these others tie in other services like Kubernetes, right? So that you can run your container orchestration and so forth. Other portions here, particularly around Heat and Mistral and Zenlin and so forth, those are building in the automation. And from those, you control policy over the organization. So it's an automated process. They're not requiring a user to sit there and watch the glass.
You may repeat this a little bit more. When we create an API, Magnum, for example, Magnum will manage Kubernetes, but it can also manage Docker Swarm. The API is consistent. We want people to be able to bring their own drivers and their own preferred solutions to solve their problems and give them a way to expose it to their users that's consistent and repeatable across those solutions.
So we do have APIs for everything.
Yes. Okay, so yeah, as Chris was mentioning, we do have an API for everything. That was actually my next slide. Great feed in. So part of that technical vision it goes along with that is the technical design that's part of that. And so they've outlined some of the do's and don'ts in that area, right? So first off, don't require a layer underneath OpenStack itself, right? Provide the tools that need to operate your data center. Okay, look at your data center holistically and make all those resources available to consumers. Okay, so that has implications on OpenStack isn't just for virtual machines, but all the other technologies that we're seeing rolling out, right? The containers, and containerization, the bare metals, and so forth. Play well with others. Encourage additional layers of abstraction. So one of the big efforts we've had the last couple of years within the community is to work well with our adjacent communities. And so we've had several folks directly working with the Kubernetes community, for example, sitting in on their special interest groups to make sure that OpenStack works very well with that technology. we've been doing the same thing with the past layers above us, right? So the cloud foundries, the OpenShifts, and so forth. So we're not trying to recreate everything. We want to make sure everything's working well together. Do software-defined allocation of resources, servers, storage routers, load balancers, firewalls, all of that, so forth. Infinite continuous scaling, right? We're going to see some big clouds in the future. Allow developers to build reliable applications. Do secure, customizable integration. Abstract out specialized operations. And this is kind of what Chris was referring to, right? So if you think about Trove or Cinder, for example, it's an abstraction. Think about the hypervisor controls. It's an abstraction that enables you to plug in other technologies into those areas without having to expose those specifics to those services. So that's part of where we get the power through our APIs is we're abstracting those specialized operations. And then the last one here, visual workflows for discovery. Okay, provide a visual way for people to discover those services. Any questions? All right, so how does this all fit together? And how does it fit with everything else, right? And really what at a very high business level, what this OpenStack infrastructure is enabling you to do is manage those demands on your organization. Organizations are becoming very fluid, rapid change. How do you do that? You can build a bunch of silos, you can buy a bunch of hardware, invest a lot of CapEx, or you can be much more agile in the way you do that. And OpenStack enables you to do that. So it enables you to do that whether you're doing cloud native, whether you're doing virtualized, or whether you're running traditional services, right? You can run that mix. You don't have to pick one and stick with it or be stuck with it, right? It enables you to do all those things. What's that? Yeah, choice with consistency. I like that. I should put that on there. Choice with consistency. So when you start to ask yourself, okay, how does this fit with everything? It starts to make you think about, so what are the trends? What's coming, right? What do I need to be adapting for beyond what I currently have in my environment? So as I thought about this, so the first trend here, and we talked about this earlier, is OpenStack adoption continues to grow, right? Huge base, as I mentioned, in private cloud, and I used Fred's quote earlier, right? About everybody's using it, particularly if you're running private cloud, it's OpenStack. What's interesting is it's not being used just in private clouds. There's all kinds of different consumption models that are being done with OpenStack. So we've got public clouds around the world that are running on OpenStack. We've got managed services. We've got managed on-prem, off-prem. All kinds of different business models are being used and adopted because of this technology, right? Second trend, and they mentioned it, Jim mentioned it this morning, and Nils and Michael talked about it as well. Hybrid and multi-cloud are definitely coming. The train's coming very fast. So he gave some statistics this morning as well. One here, 75% of the enterprises using public cloud will also use an enterprise private cloud platform. So we used to hear that everybody was going to go to public cloud and everything would go away. That hasn't happened, right? So you're going to have a mixture of clouds. Another trend that's happening is bare metal. And bare metal clouds for cloud, sorry, let me try that again. Bare metal clouds for container-based workloads is rapidly coming at us. And we could spend a whole hour talking about why that is the case, but it is happening. So again, that's one of the reasons we've got a bunch of folks that are in both communities within CNCF and Kubernetes and within OpenStack. And actually, we got a lot of the same board members. If you look at the leadership, there's a lot of overlap with that, because this is coming at us really quickly. Then the last one that I want to point out here, another trend that's happening is edge computing is coming at us very quickly. And I have another session later this afternoon which I'll specifically talk about edge. But it's an emerging model for OpenStack, and particularly for open infrastructure. And again, Orlikin, which I mentioned earlier, the guy with the bobbin, basically he's an edge deliverer, right? So it's reality for some folks today. Okay, so we talked about this. So if you've rolled out OpenStack, you've done a software-defined infrastructure, right? You've been doing this because it gives you the agility. We talk about customers being able to service themselves. You can roll out deliver new offerings quickly. You're driving efficiency, right? Driving efficiency has been the big motivator for using cloud. But that's interesting. My slides washed out, so there's a bunch of stuff here that's missing. But what we're finding is there's new cases that are driving this use, right? So if you start looking at it, you're getting a lot more data that's being stored in your cloud. You want to analyze that data. So how, again, we could talk about edge and how that's driving data, but data analytics is occurring, right? So you're getting much more data that's stored in the cloud. We're coming up with new ways to analyze that data, utilize that data. That's driving more need for agility and more workloads. We've got a lot new network use cases coming out. We talked about multi-cloud interoperability. It's going to be important. You've got to be able to improve. The whole DevOps thing is about improving developers' lives, right? And this notion of a seamless customer experience, which we talk a lot about. All of these new ideas are being talked about in the press and analysts today. Those are driving new and additional needs into your data center. And as we looked at it as a community, we basically boiled it into these notions here that what you're really doing is expanding your data center, right? So all this additional compute need and being seamless with the customer is actually driving your data centers. It means you're including in a lot of what we call adjacent technology. So things like Kubernetes and containers, all of a sudden you're pulling that technology in, doing analytics, doing blockchains, all of that kind of stuff. You're integrating in all this new type of technology. Container infrastructures is a good example of that. You're doing DevOps, you're starting to do and need automated CI/CD, right? And then, of course, edge computing. So these customer needs and expansions are driving new technologies, and as we thought about those, basically what it said is we need to evolve not just from OpenStack deployment, infrastructure as a service, but you need a very flexible and open infrastructure to work with, right? So if you noticed from the summits that we've had over the last year, we changed the name from the OpenStack Summit to the Open Infrastructure Summit, okay? And you'll notice that we've been talking about other areas outside of just the data center, talking about edge computing, we've been talking about continuous integration, we've been talking about containers infrastructure, right? A lot of those use cases and users that have been on stage, a lot of the sessions have been focused on these, what we call strategic focus areas. And so as a board, we actually approved the staff to go off and investigate these areas. And so they came up with basically 4, data center being OpenStack project itself, right? So we've been doing data center for a long time. What we realized is the infrastructure is very strong for CI/CD development. hosting container infrastructure, and working on the edge computing cases. Okay, so very far advanced on those. And so we approved the foundation to integrate and invite projects, open source efforts, around these 4 areas. And I'll talk about what those are here in just a second. So we've developed those and we've rolled those out. For 2019, the one that we're considering is AI and machine learning. Now, it doesn't mean we're going to go recreate AI and machine learning, right? What it means is we're going to put a focus on integrating with those technologies out there, making sure things work well with TensorFlow and so forth. We're not going to go recreate a TensorFlow. That's not what we do. But we want to make sure that the support for the infrastructure is there for that, right? So you could say, well, why in the heck would you focus on that one? The use cases are becoming clear. We've already been collaborating with the communities like TensorFlow and Caffe. So they are a very known entity to us. Had a lot of conversations with them, had them on stage, and we've been on stage with them and so forth. So we've got a good relationship with those communities. We already have technology being flowed into our project. So changes in Nova for support with vGPUs, for example, Cyborg for support, which is another component on that architecture list, for GPUs and FPGAs, tighter integration with Cyborg and Kubeflow and so forth. So if we look at our model, let's look at the use cases, talk about the use cases, make sure they fit in that open infrastructure, collaborate with those communities, figure out what the technology needs for those are, build those technologies in, and then going back to our model, test everything, right? Make sure it's all working. So that's what we're doing. So we go through a cycle. We've created those projects, go through a pilot phase. What we're doing now, and actually in our board meeting next week, we'll actually have 2 of those projects, which we'll start talking about creating them as confirmed projects or actually official projects within the OpenStack Foundation. And this is the 4 projects that are in those focus areas that are out there part of OpenStack today. So OpenStack, which is the data center portion, of course, is a confirmed project. Zool, we mentioned earlier where we had that our automated test check-in and test process, build process, that's Zool. So we spun that out as a separate project. It's a very mature, robust project. That's one that we'll be confirming. Starling X is focused on edge computing, and I'll talk about that this afternoon. Kata containers is a mechanism that gives you the robust securityness of virtualization with the speed of containers. Okay? So it's built off some existing technologies that's been coming together. And then Airship, which is going to give us lifecycle management, particularly the way SUSE is using that technology, is building it in to help them manage and deploy containerization. Okay? So the thing that we've been finding with this, by building in these components and working with these adjacent communities, not only is it strengthening OpenStack, but we're very much advancing these new technologies and making them robust and very usable. It's also bringing in new contributors, new lifeblood into our community. It's bringing the brand up. It's creating new movement. It's creating excitement again. And as we mentioned before, the summits are very much becoming a center of gravity for just talking about open infrastructure and not just OpenStack. All right, so with that, that's it. Any questions before we close? Too much? A little heavy? No? Great stuff? Okay, good. All right, well, thank you. Thank you for participating.